Don't forget that. I will count that wrong. Probably not today, but after this section, it will be counted wrong, so don't forget it. Page 262. We have two more examples to go through, and they are adding, subtracting, multiplying, dividing with the complex numbers. So example 6, we have 6 minus 4i plus 1 plus 3i. Again, you treat the variables just like they were in the i's, just like they were in the other variables, just like they were x's. So all you have to do here is add and subtract like terms. This shouldn't be anything new here. This should be very simple for you to do. How many real numbers do we have up there? Or numbers that you've seen before without a variable? 2, what are they? 6 and 1, and that's just what you're doing. You're adding 6 plus 1, which is 7. You can cross those off then, if you want to. And then you have negative 4i plus 3i would be what? Negative 1i. So it becomes 7 minus I. That's your simplified answer. You got to be careful with the next example. It is subtraction. 3 minus 2i. And we've got a minus in the middle. 5 minus 4i. So what would we do first there? You could do that. You could distribute the negative number in there. So if you were going to do that, I'll write that over to the side. You could do 3 minus 2i and then distribute that in, which would end up giving you minus 5 plus 4i. You can simplify it that way. If you did that, you wouldn't need the parentheses in there anymore. And that's perfectly acceptable. Then you do 3 minus 5 and negative 2 plus 4. You can do that, or you can just do 3 minus 5. All you have to do is make sure your signs are correct. That's the only thing you got to worry about with subtraction. So you could do 3 minus 5 is negative 2, and negative 2 minus negative 4 would become plus, which we changed it to over there. So negative 2 plus 4i would end up plus 2i. It's probably better to go ahead and do that, distribute the negative in. That's about the best way to make sure your signs are correct instead of doing minus negative 4. But it's whatever works best for you. They don't have any FOIL examples, so I'll just make one up because you'll have them in your homework. 2 plus 3i times 4 minus 6i. So now your operation is multiplication. You have two binomials, so you should be familiar with FOILing. So you multiply the first, that's what the F stands for. So 2 times 4 would give you what? 8. That's the first. And then you would multiply the outside numbers. 2 times negative 6i, negative 12i. And then the inside numbers would be, so plus 12i, and that would happen. And 3i times negative 6i. Negative 18, what? You got I times I there, I squared. So first of all, what happens to these two numbers? The 12s cancel, they're gone. What else do you see that we have to change? The I squared, what do we change that to?
-1.
Negative 1. So if we take negative 18 times negative 1, what do we end up with there? Positive 18. So you're going to write 8 plus 18. It's no longer negative or minus 18. It's plus 18. So your final answer would be 26 there. That's FOIL, and again, you do have some of those on the book. Last thing. I know there's been a lot of notes here. 3i divided by 2 plus 4i. So we've done add, subtract, multiply, and lastly here is dividing. Just like with radicals, you can never leave an I in your denominator. You've got to get rid of that. So what you're going to do is multiply by the complex conjugate. That's what that's called, of this bottom number. And the only thing it is the sign is different. So instead of 2 plus 4i, you're going to multiply the top and the bottom times 2 minus 4i. That's what those are called. The technical term is complex conjugate. 2 plus 4i. The complex conjugate to that is 2 minus 4i. That's all you have to do. Anytime you have this in there, in order to get rid of it, that's what you're going to multiply by. So it's probably best then to put these all in parentheses because you're going to end up having to FOIL. On the top, you don't have to FOIL, you just have to distribute. So 3i times 2, what would that give you? 6i. And 3i times negative 4i, what would that give you? Minus 12i squared. Now here's the thing on the bottom. What do you think we have to do to multiply those? What do you? What? Somebody said it is FOIL. It appears like you would have to FOIL that because there's 2 binomials there. However, when you multiply conjugates, you only have to do first and last instead of FOIL. You just have to do first and last. The reason is, anytime you multiply conjugates, this right here is going to happen. Every time you multiply conjugates, those inside terms are going to cancel. So I'm just trying to save you steps. If you do FOIL it, it's not going to change anything. You're going to end up with the same answer. I'm just trying to save you time because those will always cancel out. So all you have to do is first and last when you multiply the conjugates. So doing that, 2 times 2 here would give you 4, and then multiplying the last term, 4i times negative 4i, what would that be? Negative 16i squared. So on the top then, instead of having minus 12i, what would we have? Or minus 12i squared. Be positive 12 because I squared is negative 1. So you'd have 6i plus 12. And on the bottom, what would you have? 4 plus 16. Remember, it's not 16i. This totally changes to negative 1. So that would be 4 plus 16. Now, the very last thing you've got to do on these problems is take out any common term that you could. The best thing to do here would be just to just to split it into two fractions. Split them both into two fractions. And then simplify both fractions. So what can we take out of 6i and 20, or 6 and 20 here? We can take a 2 out, which would leave us with 3i over what? 10 plus, what can we take out of that one? 12 and 20. So we take a 4 out, we would have 3 over 5. Now, if you look in your book, what's different between our answer and theirs on page 263? You want to see a difference? They're different order. Your I value, your I part, should always come second. So whatever time you want to flip those around, you could have flipped them around, clear up here, flip the 12 and the 6i. Just make sure you do that before you finish the problem. The imaginary part should always come second. 3/5 is a real number. This part right here, that's a real number. This is imaginary. That's what makes it complex. It has real parts and imaginary parts. And the imaginary always has to come second. We'll do one more of those and we'll get on your way. Negative 2i over 3 plus 5i. So same thing as the last example. What do we need to multiply by? What? On the top and bottom. 3 minus 5i. So on top, we just distribute the negative 2i again. Negative 2i times 3, negative 6i, and negative 2i times negative 5i would be plus 10i squared. And then on the bottom, again, we just have to do first and last. We don't have to FOIL it. So 3 times 3 is 9. 5i times negative 5i. Minus 25i squared. So on top, what's that going to become? Negative 6i. What happens to the 10? Negative becomes negative. So negative 6i minus 10. And on the bottom, you're going to end up with 9 plus 25. So 34. So you could flip that around now. You could put the 10 first. Negative 10 over 34. And negative 6i over 34. So what can we take out of 10 and 34? What? A 2. So negative 5 over 17. And what can we take out of 6 and 34? Also a 2. So 3i and 17. Homework. Let's do 22 through 44 even. That starts on page 264. And then 54 through 68.